The commutative property of addition states that changing the order in which two terms are added does not change the answer, does not change the sum. 2 plus 6 and 6 plus 2 are both 8. The commutative property of multiplication is similar. Changing the order in which two factors are multiplied does not change the product, does not change the answer. 2 times 6 and 6 times 2 are both 12. Rewrite each expression using the commutative property of multiplication or the commutative property of addition. Y plus 9 is equal to 9 plus y. C times negative 7 is equal to negative 7 times C, written without parentheses as negative 7C. Negative 3 plus 6w is equal to 6w plus negative 3. Adding a negative number, we could write this more simply as 6w minus 3. A times C is the same thing as C times A. We could drop the parentheses if we wanted to and write CA. 4x minus 5 means 4x plus negative 5. Applying the commutative property of addition, we would write negative 5 plus 4x. Calculate the problem using the appropriate commutative property. If we wanted to, we could change the order of the 18 and the 69, and that would give us 42 plus, here's where the commutative property of addition comes in, 18 plus 69. Changing the order in which two terms are added does not change the sum. Now 42 plus 18 is 40, plus 10 is 50. 2 plus 8 is 10, 50 plus 10 is 60. 69 plus 18 was rewritten as 18 plus 69 in order to have the 42 and 18 side by side, which gave us an easy calculation of 60. So then we have 60 plus 69. 60 plus 60 is 120, plus 9 is 129. If we use the commutative property of multiplication, we can change the order of these two without changing the overall value of the expression. So we have 5 times 2 times 14. 5 times 2 is 10. So we have 10 times 14, and that's 1, 4, with that 0 on the end. In other words, 140. Simplify the problem using the appropriate commutative property, then combine like terms. First, let's write each subtraction as plus a negative number, or plus a negative term. Then we will change the order in which these two terms are written using the commutative property of addition. So we have 5a plus, we'll write negative 13a first, plus negative 83. 5a and negative 13a are like terms. Therefore, we will add their coefficients, 5 plus negative 13. 5 plus negative 13 is the same as 5 minus 13. Here's a quick way to compute smaller number minus larger number. Turn them around. Compute 13 minus 5, which we all know is 8. Therefore, reversed, 5 minus 13 is negative 8. So 5a plus negative 13a is negative 8a. Adding two like terms produces the same like term. We therefore have negative 8a plus negative 83. These two terms are not like terms. We cannot combine them or simplify them down to one term. So that is a final answer. Except we often don't leave an expression written as plus a negative number. We write subtraction instead. Negative 8a minus 83. Simplify using the appropriate commutative property, then combine like terms. Let's rewrite subtraction as plus a negative. Likewise, minus 5y is plus negative 5y. If we change the order in which these two terms are added, first of all, we don't change the overall value of the expression, but also changing the order of those two terms, we'll put like terms side by side. We'll have 8x plus, here's a commutative property of addition coming into play, 2x plus negative 3y plus negative 5y. 8x plus 2x, those are like terms. 8 plus 2 is 10. Therefore 8x plus 2x is 10x. Like terms added together produce a term like them. Negative 3y plus negative 5y are like terms. Their coefficients, negative 3 plus negative 5. We're adding together two negatives, so we add their absolute values. 3 plus 5 is 8. Therefore, negative 3 plus negative 5 is negative 8. We have 10x plus negative 8y. Adding two y terms gives us another y term. We do not leave an answer as plus a negative. We write subtraction instead. We have, therefore, 10x minus 8y. Simplify the problem using the appropriate commutative property, then combine like terms. The commutative property allows us to switch terms, switch the order in which they are written, as often as we like. So we would change the order several times so that the a terms are written side by side, 7a plus 4a, and then the constant terms would be written side by side, plus 3 plus 1 minus 5. For the a terms, we will add their coefficients, negative 7 plus the implied coefficient of 1 that is there, plus 4. We have negative 7 plus 5. If you lost $7 but earned back 5, is still in the hole but only 2 in the hole. We indicate that with negative 2. And adding together a terms gives us another a term. So we have negative 2a. Let's add the constant terms now. 3 plus 1 is 4. We have 4 minus 5. Remember that to take smaller minus greater, we can do the more comfortable subtraction, greater minus smaller. It gives us 1. The reversal of those 4 minus 5 is negative 1. So we have negative 2a plus negative 1. We don't leave a final answer with plus a negative number. We write subtraction instead. We have negative 2a minus 1. The associative property of addition states that the grouping of terms that are being added does not change the sum. If we have three numbers to add together, 4 plus 6 plus 2, we can either group the first two numbers together, as we see over here, getting 10, then adding the 2 and getting 12, or without changing the order, we can group the second two numbers together. 6 plus 2 is 8, and then do 4 plus 8. We get 12, the same answer. Rewrite the expression using the appropriate associative property. Well, we see three different numbers being added together, y, 8, and 4. Y plus 8 are grouped together. The associative property says an equivalent expression will come from grouping the second two terms together. So we have y plus the quantity 8 plus 4. The associative property of multiplication says that if we regroup the numbers being multiplied, we do not change the overall value of the expression. In this example, we have three numbers being multiplied. 5 is multiplied with 7, is multiplied with a. On the left, these parentheses indicate that 7 times a are grouped together and multiplied. The associative property of multiplication says we get an equivalent expression by making this grouping the 5 times the 7 together. Show that this statement is true by showing the associative property of addition is being used and is valid. Notice we have the same three numbers, 7 plus 4 plus 8, 7 plus 4 plus 8. On the left-hand side, the 7 and the 4 are grouped together, giving us 11. So we have 11 plus 8, which we know is 19. Now on the right-hand side, The parentheses group the 4 plus 8 together, giving us 12. So we have 7 plus 12. That is also 19. The associative property of multiplication will be used here to show that the left-hand side and the right-hand side, these two expressions are equivalent. Notice we have the same three numbers being multiplied. 2, 7, and 9. 2 times 7 times 9. On the left-hand side of the equal sign, it's the 7 times the 9 which are grouped together. 7 times 9 is 63. So we have 2 times 63, which is 126. On the right-hand side of the equal sign, the 2 and the 7 are grouped together in multiplication. 2 times 7 is 14, so we have 14 times 9. 36, 3, 9 times 1 is 9, carry 3, 126. Simplify the expression using the appropriate associative property. The associative property of addition allows us to add the same three numbers, not changing the order. Those numbers are y and 8 and 4. But instead of grouping the first two terms together, which is really not very beneficial as they are not like terms, we can instead group the second two terms together, which happen to be like terms. So at this point we have applied the associative property of addition. But look what's inside the parentheses. That grouping is a grouping of like terms, of constant terms. 8 plus 4 is 12, so we have y plus 12. And again, we can go no further because y and 12 are not like terms. Simplify the expression using the associative property of multiplication. We have three numbers being multiplied, 5 times 7 times 8. We write them in the same order, but instead of grouping 7 times a together, we will group 5 times 7 together. 5 times 7 is 35, so we have 35 times a. That multiplication dot is usually suppressed, in other words, not written, and we get 35a. Simplify the expression using the appropriate associative property. We will use the associative property of addition. We write the same three terms down in the same order. On the left-hand side, 4a plus 6, those two terms are grouped together, but that's really not beneficial because these are not like terms. We cannot add them. You don't get 10a from this. Parentheses are unsimplifiable here. The associative property of addition allows us to change the grouping. We will group the first two terms together, 9a plus 4a. That is beneficial because those are like terms. 9a plus 4a is 13a. So we have 13a plus 6. This goes no further because 13a and 6 are not like terms. We will use the associative property of addition to simplify this expression. The terms being added are 15x plus 7 1/3 plus 4 2/3. On the left-hand side, these first two terms are grouped together, but they are not like terms. One of them has x, one of them does not. So there is no simplification inside the parentheses. The associative property says we can group the second two terms together, so that is 15x plus the quantity 7 1/3 plus 4 2/3. Inside the parentheses, we can add those together. Those are constant terms. They are like each other. We can add them. How do we add them? We can get fancy about it, or more simply, here's 1/3. There's 2/3. 1/3 plus 2/3 is 1. 7 plus 4 is 11. 11 plus 1 is 12. So we have 15x plus the result of our parenthetical computation is 12. We can drop those parentheses and just simply write 15x plus 12. We can go no further because 15x and 12 are not like terms. The identity property of addition says that the sum of any number n 0 is that same number. Likewise, the sum of any term n 0 is that same term. For example, 6 plus 0 equals 6. 2x plus 0 equals 2x. The identity property of multiplication states that the product of any factor and 1 is that same factor. 6 times 1 is 6. 2x times 1 is 2x. Complete each equation using the appropriate identity property. 8a plus 0 equals 8a. 9y times 1 equals 9y. 0 plus what gives us 13w? Answer, 13w. 6a times what gives us 6a? Answer, 1. 6a times 1 is equal to 6a. The inverse property of addition states that the sum of a number and its opposite is 0. 4 plus negative 4 is 0. Similarly, with terms, the sum of a term and its opposite is 0. 2x plus negative 2x is 0. The inverse property of multiplication states that product of a number and its reciprocal is 1. 5 times 1/5 is equal to 1. That's true for all real numbers except for 0. 0 does not have a multiplicative reciprocal. It does not have a multiplicative inverse. In fact, 1 divided by 0, the supposed reciprocal of 0, is not defined. So this here is true as long as number a is not 0. Complete each equation using the appropriate inverse property. 7 plus what quantity gives us 0? The answer would be the opposite of 7, which is negative 7. 3 times what quantity gives us 1? And the reciprocal of 3 is 1/3. 3 times 1/3 is equal to 1. In part C, we have w plus negative w equals, well, this is simply a number plus its opposite, and the answer is 0. Part D, negative 5 plus what number is 0? So we're looking for the opposite of negative 5, because the opposite of this number and that number would give us 0. What is the opposite of negative 5? 5. So negative 5 plus 5 is 0. In part E, we have 1/5 times some number is equal to 1. A number times its reciprocal is 1. So what is the reciprocal of 1/5? 5 divided by 1, or 5 over 1. More simply, 5. Part F, we have negative 3x plus 3x. Here we have a term and its opposite being added together. The answer is 0. And in part G, 4x times what quantity gives us 1? Since that's multiplication, the answer is the reciprocal of 4x, which is 1. Some people say 1 over 4x. That's really 1 divided by 4x. Now on this last page, we have a summary of the different properties that we have looked through in this section.